You can perform crunches until your abdominal muscles burn, but that effort alone won't actually make them visible. The human body cannot burn fat directly over the muscle you are exercising. Contracting your abs 1,000 times builds the tissue underneath, but leaves the layer of abdominal fat entirely intact. To see physical definition, you have to solve two distinct physiological problems. You need localized muscle growth to build the structural foundation, and a systemic caloric deficit to strip away the fat hiding it. Normally, achieving both requires splitting your time between heavy resistance training and long cardiovascular sessions. But executing a mountain climber with precise, perfect form turns the exercise into a highly specialized biomechanical tool. By placing the upper body under constant static tension while forcing the lower body into a full sprint, you trigger a physiological response that demands core stabilization and high cardiovascular output at the exact same time. To see how this works, we have to look at what the upper half of the body is doing. Before a single leg even moves, you are locked into a high plank position. Your shoulders, chest, and the muscles along your ribcage, the serratus anterior, must fire to lock your torso rigidly in place. To keep your spine from collapsing toward the floor under the weight of gravity, the deep core takes over. Your transverse abdominis wraps around your midsection like a corset, while your rectus abdominis, the six-pack muscles, contract to hold a neutral spine. Driving your knees forward introduces rapid kinetic shifts. Your legs act like levers, generating torque that pulls your pelvis and lower spine out of alignment. To prevent you from twisting, the internal and external obliques running along your sides have to contract intensely. They act as anti-rotational stabilizers, fighting the force of your legs to keep your hips square to the floor. Your upper body is engaged in a continuous, multi-directional battle against gravity and rotation. That sustained tension is the primary driver of core strength and stability. Beneath that rigid upper body, the lower half is running a pure cardiovascular sprint. Your legs are acting like pistons. Every time you drive a knee toward your chest, your hip flexors and quadriceps fire. As you kick back, your hamstrings and glutes forcefully extend the leg. Rapidly moving the body's largest muscle groups requires massive amounts of cellular energy and oxygen. You are demanding all of this while your core is tightly braced, which restricts your breathing mechanics. Looking at this animated bar chart, we can see how the metabolic cost compares. While standard planks or crunches burn calories at a low, steady rate, the intense demand of the mountain climber spikes your energy expenditure up to 8 to 12 calories per minute. As this chart morphs into a line graph tracking your caloric burn over time, notice what happens after the workout ends. The high metabolic demand placed on your system forces your body into a state called excess post-exercise oxygen consumption, or EPOC. Watch how the area under the curve fills in during the recovery phase. Your body is working overtime to restore oxygen levels and repair muscle tissue, which means you continue burning calories for hours after you step off the mat. That sustained post-workout caloric deficit strips away the adipose tissue, allowing the abdominal muscles you built during the stabilization phase to finally be seen. This dual-engine response depends on maintaining mechanical precision. When form breaks down, the stabilizing and metabolic benefits are lost. The first major error is piking your hips up toward the ceiling. This creates a triangle shape that removes your abdominal tension and shifts your weight backward, turning a core exercise into a mild shoulder stretch. Letting your hips sag toward the floor is worse. As your abs disengage, gravity pulls your pelvis down. This skeletal view shows how that sagging transfers your body weight directly into your lower back, creating compressive stress on the discs in your lumbar spine. Once you establish perfect form, you can alter the mechanics to target specific goals. If you drive your knee across your torso toward the opposite elbow, you perform a cross-body climber. This creates an intentional twist, forcing your obliques to work harder to stabilize the rotation. If the standard version is too demanding on your wrists and shoulders, you can elevate your hands on a bench or step. This incline shifts your center of mass backward, reducing the weight load on your upper body while still delivering a cardiovascular and core workout. You don't need heavy weights or hours on a treadmill to build physical definition. By understanding the biomechanics of your own body, you can turn a single patch of floor into a complete cardiovascular and core sculpting machine.